Hey guys, welcome back. We are with the very demanding topic, and that is called as electrolysis. Yes, electro, and then the other word is lysis. Okay, what is the meaning of electrolysis first of all? Sometimes the examiner is asking in the exam, define electrolysis. So it means that we must have a very productive and a proper type of definitions. Okay, so it is a process in which electricity is passed through a substance through a substance bracket, you may write through an ionic compound, either in the molten state. Is that only for the electrolysis is only for the ionic compound? Yes. Okay, either in the molten state or in the solution form or in the solution state, you may say aqueous state, and it converts itself into its components. That is called electrolysis. So what is electrolysis? When we are passing electricity through an ionic compound, either in the molten state or in the solution state, we may call solution state as an aqueous state as well. Because in the aqueous state, what is the basic meaning of aqueous state? We are just adding water to a substance. So that substance has water now, so that is called as the aqueous state. So we are passing electricity through that, and a chemical reaction is happening. As a result of that chemical reaction, what is the basic result? That the components are formed for that substance. That substance is converting itself, it is breaking up itself into its components. Yes, that's it. Okay, so this is what called electrolysis. Here I am writing on the softboard, so I am taking a little bit longer space. There will be like two lines, you people can write it. There is no need to write it's a process, and it's a process. These words can be omitted as well. So you may say this thing, that electricity is passed through an ionic compound bracket molten slash solution, and the compound converts itself into its components. That's it. Okay, so this is what called electrolysis. Before moving ahead, there is a big story of electrolysis which students should know as a base before starting the electrolysis in detail. Okay, what is that story? In this story, basically, one should know this thing, that there is a process which is called conduction. Okay, what is conduction? A process in which electricity is passed through a substance. That's it. Okay, a process in which in which electricity is passed through a substance. Okay, guys, before moving ahead, I would like to inform you that there are two types of the conduction. Okay, what are those two types? One of them is called electric conduction, and the other is called electrolytic conduction. Okay, now what is electric conduction? We may say when electricity is passed, sorry, due to lack of space, I have to make this pen thinner. When electricity is passed through a metal or an alloy or through graphite, and no chemical reaction is occurring. Is occurring. Okay, so one should know this thing, that no chemical reaction is occurring. Okay, now what's happening in the electrolytic conduction? Better is this to go on to the next page. In case of electrolytic conduction, what's happening electrolytic. Electricity is passed through an ionic compound. In the bracket, I'm writing molten slash aqueous and a chemical reaction occurs. So this is the second type of conduction, you may say. So conduction has basically two types. One of them is electric conduction, whereas the other is called as the electrolytic conduction. Definition of electric conduction is related to the passage of electricity when there is no reaction is happening, and when it is occurring, when electricity is passed through all metals, when electricity is passed through any alloy, or when electricity is passed through graphite. Okay. I would like to give you a reminder of electricity conduction through ionic compounds and through covalent structures. When I have taught you all these things in the topic of bonding, I'm going to give you a review of that as well on the next pages. Okay. Guys, try to recall this concept that there was electricity conduction through metals, for example, through all metals, okay, plus alloys. And you should recall that graphite has also free electrons. Okay, so these are the ones for which we can say conduction due to mobile electrons. Conduction due to mobile electrons. And the next state is the next point related to this is in all states. In all states, it means that molten metal will conduct electricity, solid metal will conduct electricity, things like that. Okay, if we are talking about the ionic compounds, okay, let's discuss the ionic compounds. In case of ionic compounds, electricity is conducted only in molten and in solution state. Why it is so? Because of the availability of mobile ions. Okay, so next point is this, that in the solid state, no conduction, no conduction is possible through an ionic compound. And why it is so? Not available mobile ions. Okay, not availability of mobile ions. Okay, no mobile ions. No mobile ions are available. Okay, so this is the story about the ionic compound. Let's move on to the covalent structures. Okay, covalent structures. Covalent compounds, you may say. Covalently bonded molecule or covalently bonded compounds. Covalently bonded molecules like Cl2, H2, covalently bonded compounds molecule, or you may say molecule of compounds which are covalently bonded. They are like CH4, like CO2, like NH3, like H2O, etc. Yes, I will discuss on H2O, don't worry about that. Covalent structures never conduct electricity, never conduct electricity, except there is one, and you know this, electricity and why they cannot conduct electricity? Due to unavailability of what? Of mobile electrons. Okay, done. Then what is this? Never conduct electricity except there is one exception. And what is that except graphite? And what is happening in case of graphite? Just recall that concept I have taught you in the bonding topic. You can look at that video again. In that topic, I have told you that each of the carbon atom is making three bonds with three of the carbon atoms. And as each of the carbon atom has four electrons in its outermost shell, hence it is just utilizing three electrons from the outermost shell, whereas one electron is remain non-bonded, remain unbonded. As a result of that, each of the carbon atom can utilize that electron for the conduction of electricity. Due to availability of that mobile electron, electricity can be conducted through this graphite thingy. Okay, so you may say electrons are available, mobile electrons. This mobile is the targeted term. Okay, this term must be written in the paper. Mobile electrons are available. if you will read the mark scheme, you can look at these definitions that that the examiner is writing the word of mobile in the mark scheme. Okay, so this was the story about conduction. After detailed explanation about electrolysis, this was the story about conduction, and now we are moving on to the next page, and that is after conduction there is a next definition. You all know this thing already, and that is called a conductor. A conductor is a substance which allows the passage of electricity through it. Okay, a conductor is a substance which allows the passage of electricity through it. So we can give the example of metal, we can give the example of alloy, we can give the example of graphite, we can give the example of all ionic compounds, all ionic compounds. Either you have to write it here very clearly. If you will not write, it will not give you any credit. All ionic compounds either in the molten state, molten state, or in the solution form, in the solution form. Okay, this is one of the thing which you people should know. Okay, now there is another thing, and that is called as insulator. Okay, insulator, you people already know about the insulator as well. Never conducting electricity. Okay, never conducting electricity. Now the point is this, that why they can never conduct electricity, due to unavailability of mobile electrons or due to unavailability of mobile ions. Okay, due to unavailability of mobile electrons and due to unavailability of mobile ions, as these are not under the category of metals, alloys, or they are not under the category of the ionic compounds as well. So that's why they can never conduct the electricity. Then there is another story, that what are the examples of the insulator. You people know these examples already. That is glass, for example, that is for example a plastic, you may say a fabric, and then we can talk about the wood, so etc etc. These all are the examples of the insulators. There is one term called semiconductor as well. Semiconductors are those substances which can conduct electricity sometimes upon heating. So sometimes they are not conducting electricity in their colder states, but they can conduct electricity when they are heated. For example, silicon is one of the substances which can conduct electricity when it is heated. Okay, so these are the general types of the definitions and the basic background which a student should know before starting the electrolysis. Okay, now I am on the next point, and after the definition of conduction, conductor, insulator, and semiconductor, different types of the conduction as well, we are right now on the next thing, and that is called as electrolyte. Yes, this is a new thing. Electrolyte. It is an ionic compound. Yes, specifically. Now we are out of the range of the metals and alloys. Specifically, we are on the ionic compounds. Okay. It is an ionic compound either in the molten state or in the solution form or in the solution state. Electrolyte is an ionic compound either in the molten state or in the solution state, which can which can conduct electricity, which can conduct electricity. And why? Due to mobile ions. Okay, so this is the mobile ions, and a chemical reaction is associated with it, associated with this passage of electricity. Okay, and a chemical reaction is associated with this passage of electricity. Okay, so this is what called electrolyte. So for example, we may give the example of NaCl. Okay, it's an ionic compound. It can be used as an electrolyte as well in the molten state or in the solution state. Then we can take the example of, for example, AgCl. In the molten state, it can conduct electricity, or we can say that there is an example of potassium bromide as well. So these are the different examples of the ionic compounds which can conduct electricity. Okay, so these can be considered as an electrolyte as well. Then I am on the next page, and there is a next term which is called as electrode, which is called as electrode. Guys, before moving ahead, I would like to draw this diagram, okay? And this is what? This is a battery, for example, this and this, okay, done. This and this and this. All right. So, unfortunately, I have not made them of the similar size. You may consider this is now equal. Okay. So, this is the positive terminal of the battery. This is the negative terminal of the battery. And these two, the rods or the places, the platforms which are attached with the positive terminal of the battery and the negative terminal of the battery, you may say these are the surfaces which are attached with the positive and the negative terminal of the battery are called electrodes. So what we can say about electrodes, electrodes are the surfaces which are attached with the positive and the negative terminal of the battery on which chemical reaction of electrolysis occurs. Okay. For the chemical reaction of electrolysis, we are expecting a place. We need a place where the chemical reaction can occur. Why chemical reaction is occurring? What is pushing for that chemical reaction, how electricity is coming to the solution, what is the way to come to the solution for the electricity. So these are the surfaces on which the chemical reaction of electricity electrolysis is happening basically. Okay, so basically there are two types of the electrodes, we may say. One of them is depending upon the charge. Okay, depending upon the charge, we have two types of the electrodes. One is positively charged electrode, the other is negatively charged. Positively charged is that which is attached to the positive terminal of the battery. Similarly, negatively charged will be that which is attached to the negative terminal of the battery. So positively charged is called as the anode, whereas negatively charged is called as the cathode. Now the point is this, that towards anode, which is positively charged, negative ions will be attracted. Negative ions will be attracted towards a positively charged electrode. Okay, and these negatively charged ions are called as anions. Why these are called as anions? Because anions are attracted towards anode. So the ions which are attracted towards anode are called anions, but definitely both of these must have an opposite charge. That's why they are being attracted towards that. So in the same way, cathode, and here we are writing that in towards cathode, we can say that positively charged ions will be attracted, and then we can say that these are called as cations. Okay, guys, sometimes students get emotional, and instead of saying anions they are saying anions, and instead of saying cations they are saying cations. So please don't say such type of words. These are the wrong pronunciations. So it is cations and anions for these ions. Okay, cations are those ions which are attracted towards cathode, and anions are those ions which are attracted towards anode. So obviously, cations have a different charge and cathode have a different charge. Similarly, anions have different charge and anode has different charge. But the point is this, what you can keep in your mind is that anode is a positively charged electrode, whereas cathode is a negatively charged electrode attached with the positive and negatively charged terminals of the battery respectively. Okay, now I am telling you that electrodes can be divided into two parts, two types, depending upon their materials as well. So, what is that division? Materials. Okay. So, number one are called as inert electrodes. Inert electrodes. The word of inert is already used for so many times before, but I would like to explain this thing again. And the other is called as active electrodes. Okay. Guys, let me explain this thing, that in case of inert electrodes, basically, made up of either graphite or platinum. Yeah, platinum. Platinum is a metal. It's generally called white gold, okay? But it is not white gold. It's not gold. Gold is another metal, and platinum is another metal, and platinum has a symbol of Pt. It's a transitional block element, okay? So let's discuss about inert electrodes. Okay, one thing is this, that they are not participating. not participating in the chemical reaction of electrolysis. Not participating in the chemical reaction of electrolysis. Okay, then number 2 point is graphite is preferred. Graphite is considered better, and why it is so preferred? As cheaper, as cheaper as compared to platinum, much cheaper, as cheaper as compared to platinum. Now, the point is this: platinum is a metal. Why it is considered as an inert electrode? Platinum is a metal which is of very, very low reactivity. That's why it is considered as a very poorly reacting metal. You may say it is unreactive metal. It's not. We may not consider that as an element of group number 8, but definitely some of the metals have very, very poor reactivity. For example, you have seen people wearing gold rings and then they are washing their hands in cold water, in hot water, sometimes in while cooking or stuff. Sometimes their hands are going into vinegar, and sometimes there are certain types of the salts in the food, etc., etc. So we are observing that people are using that thing, and no reaction is happening on their hands. So it means that gold is also one of the metals which has quite very lesser in the reactivity, which has quite very less reactivity. In the same way, we can talk about the platinum. Platinum is lesser in the reactivity even as compared to gold. So just imagine from that. And now we are on the next point, and that is related to the active electrodes. Okay, these electrodes, we are just talking about them. These electrodes are playing their own role in the electrolysis. Okay, they have they have their their own role in electrolysis, and products of electrolysis are based upon these electrodes. Yes, and I'm moving on to the next page. For example, I'm writing here that it is a continuation of active electrodes. So we can say this thing that here in this case we can talk that active electrodes examples are, for example, copper electrodes in the electrolysis of copper sulfate solution. You may say electrolysis of silver nitrate using silver electrodes. So these are the examples. There can be many others, but these are the examples of the active electrodes. Okay, these are the examples of the active electrodes. Okay, done. Now after telling you what are the electrodes and what is the electrolyte, etc., etc., now we are moving towards the next setup, and that is called as the types of the electrolysis, which we are going to study in your syllabus. Okay. Now, number one is this. I am writing here. Electrolysis of the following types will be studied in your syllabus, and number one is number one, number two, number three, and number four. Okay, yeah, it is called as the molten compounds electrolysis. Then it is dilute solution electrolysis. Then it is concentrated solution electrolysis. Active electrodes electrolysis. There are two other cases which I would like to write here. Applications of electrolysis. There are two applications which I will teach you in detail, inshallah. Applications of electrolysis, and then, I'm sorry, I have to write here, electric cell. So you may consider that this will be the number one part, this will be the number two part, this will be the number three part, this will be the number four part, and then I will come on the applications number five part, and this will be the number six part. I have numbered them so that you people may find it easier to place it, that which will be done and when it will be done. Is that okay? So I would like to inform you a little bit information about the molten, okay? Molten ionic compounds electrolysis. The point is this: molten. What is the meaning of molten? Guys, you people have seen this thing in every birthday, that whenever a candle is light up, what is happening? We are not adding water into it, but the candle is getting melted. The wax of the candle is getting melted due to that heat. So we are not adding water into it. Similarly, when we are placing a chocolate in a double boiler, what is happening? What is a double boiler? It means that water is in one container and there is another container containing chocolate, and that container is placed into the water. Okay, it is not in direct contact with the burner. Rather, burner is giving the heat to water, and then that heat from the water is supplied to the container having chocolate. We are observing this thing, that chocolate is getting melted with the passage of time when it is receiving heat. We are not adding water into it, we are not adding any other liquid into it, but it is converting itself into the liquid state due to that heat. So that is called as a molten state. Okay, that is called as the molten state. Okay, so this is the one which you people should keep in your mind, that students are sometimes asking me that how something can be in the molten state or the liquid state without water or something. I am just telling you again that it is due to heat. We are supplying heat to a compound, and the compound is converting into its melted state. That melted state is called as molten state. Okay, that melted state is called as molten state. That's why I have given you a daily life example. One of them is candle wax, whereas the other of them is molten chocolate. Okay, so it is a molten state having no water, having no water added. All right. Okay. I'm going to continue from this topic, inshallah. All the best to all of you. See you in the next class. Maybe you all have a good day.